So this is for module 6.3, hypotenuse leg triangle congruence. So the essential question is, what does the hypotenuse leg triangle congruence theorem tell you about two triangles? The shortest answer is basically if a leg and hypotenuse of one right triangle are congruent to the corresponding leg and hypotenuse of another right triangle, the two triangles are going to be congruent. Okay, so basically, let me just draw it real quick. You have, that was a terrible line. There we go. You just bought a tent, and it's a really interesting tent. Okay, it's a right triangle tent. Okay, and you look over, and guess who's over there, right? It's Jim. Okay, he also bought the same kind of tent. Okay, sorry, the drawing's a little off, but hey, use your imagination. All right, and basically you realize, hey, my little leg here is the same as Jim's little leg. Okay, and this is what we say leg. And then, hey Jim, how long's your roof, your top, your hypotenuse? And Jim goes, oh, it's the same as yours. And it's like, is this one of those special right triangle tents, Jim, that you bought? And he's like, yeah. And it's like, oh, well, yeah, that's actually a theorem. So basically, if your legs are the same and your hypotenuse is the same, and it's a right triangle, they're congruent. No questions asked. All right. So let's look at justifying the hypotenuse leg congruence theorem. So basically, again, in a right triangle, the side opposite to the right angle is the hypotenuse. Okay, that's important to know. So again, across from the 90 degrees is the hypotenuse. That's very important to know, especially when we get into trig later on. Okay, so just remember, across from the 90 degree is always going to be the hypotenuse. Now, the two sides that form the sides of the right angle are the legs. So it could be this guy right here, or it could be this guy right here. Okay, it really just depends on what's given to you. All right. Now, just to recap, there are four ways that we have proved that triangles are congruent. We used angle side angle. We used side angle side, side side side, and yesterday angle angle side. Okay, this is one of the last triangle congruencies that we have, which is basically just hypotenuse leg triangle congruence. So again, here's the theorem itself, which I explained already. Basically, again, you have two right triangles, and you have a leg that is corresponding to another leg, and a hypotenuse corresponding to another hypotenuse. If they are congruent to each other, then those triangles are congruent. Okay. Just remember, it only works with right triangles. That means 90 degrees. Okay, you have to have a right angle. If you don't see a triangle with a right angle or a 90-degree angle right there, HL is not even, shouldn't even be in your head. All right, so proving this thing. All right, so we have that these guys and these guys are right triangles. Okay, that's good to know. So 90 degrees, 90 degrees. That was given. And then C and F are right angles. That was also given. That's good to know. Which makes sense because they're both 90s, right? And then AB is congruent to DE. All right, so AB is right here. The hypotenuse is congruent to the other triangle's hypotenuse. And then BC is congruent to EF. That's really good. Okay, so that's actually giving us a leg and a hypotenuse. Now we just have to prove that these two triangles are congruent. And they kind of give us a hint by giving us this little a, this little c, and this little b. What are they trying to go for here? Is they're trying to go for the idea that, well, if we have these two sides, right? So if you think about side, 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 for example, we have two sides already, right, given to us. And we're going to use side, side, side. So that means we have to prove that this AC is going to be congruent to DF. So let's go ahead and start with what's given to us. So we already know that angle C is going to be congruent to angle F, and that's because the definition of right angles. Thank you, little touchscreen, for doing that. So again, right angles. And that gave us, the right angle a little bit, okay? They also said that AB is congruent to line segment DE, given. It's always good to start off with what was given to you. And then BC is congruent to EF. Very nice. And now we have two right triangles. Now, to find the missing side of any right triangle, we use Pythagorean theorem. So we're going to use it to actually prove this, okay? Because we need another side. We need this side to be congruent to the other corresponding side, all right? So let's go ahead and do that. Hold on. Technical difficulties. There we go. All right. So we have a squared plus b squared equals c squared. Okay. And that's for the first triangle, for triangle ABC. Then for triangle DEF, most def, okay, we have d squared plus e squared equals f squared. Now, didn't they tell us that AB, which is really just C, okay, is congruent to DE, which is really just F? Yeah, they did. So let's set these guys equal to each other. This guy should equal this guy, all right? So here we go. A squared is really just BC squared, right? B squared is really just AC squared. And again, we can set them equal to d squared, which is EF squared, plus DF squared. And didn't they say that BC is congruent to EF? So these guys can cancel out right away, okay? Square root both sides, and we just proved that AC is congruent to DF, all right? Which means we just got our third side, which basically says triangle ABC is going to be congruent to triangle DEF, okay? And that is by side, 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 triangle congruence theorem. Awesome. Okay. There we go. So again, we use Pythagorean to set these equal to each other. And again, c squared and f squared was really just taken care of by this. Okay, AB being congruent to DE. So we just set them equal to each other. All right, so your trick number one, again, this is a proof. Prove that these two triangles are congruent. And try to use HL triangle congruency. Okay. Also, do we have the reflexive property? So try to prove it. See what they gave us. All right. And that should help you go into it. Now, do you need to use Pythagorean theorem? Because you need a hypotenuse, a leg. They are both right triangles. They gave that to us. So try to construct the proof based upon what they gave us. Okay. All right, so applying the HL triangle congruence theorem, basically they went ahead and told us these two guys are right triangles. That was given. And then basically we can surmise they gave us PS is congruent to RQ, which again was given. And then basically we just have to say, well, SQ is congruent to SQ, and that's because of the reflexive property right here. They both the triangle here and this triangle here share the same hypotenuse. That's the reflexive property, okay? So that is the hypotenuse. And we know that this is basically a triangle. So, and they also gave us this, which is a leg, which is congruent to this leg. We have two right triangles, same hypotenuse, same legs, and therefore these two triangles are congruent by the hypotenuse leg triangle congruence theorem. Don't forget about the reflexive property, very powerful. All right, so applying triangle congruence theorem, they go ahead and give us this. Okay, that was nice of them. How nice. And then K is a midpoint. So K is a midpoint of JL and MN. So JL and MN. So if this guy's in the middle, this distance from KL is going to be the same as the distance from JK, not JK. And the distance from KM is going to be congruent to the distance from KN. Okay, and that's basically a definition of a midpoint. Okay, and again, this was given. They told us that K is a midpoint. Okay, very nice. All right, so again, just like how I said it, those guys are all congruent to each other because that's the definition of a midpoint. Okay, it's good to know the definition of a midpoint. All right. All right, so let's look at it. We have a leg congruent to another leg. These are both right triangles, so that's good to know. We have a hypotenuse that is also congruent to the other hypotenuse. So these two triangles are congruent by the hypotenuse leg triangle congruence theorem. Very nice, very nice. All right, your turn number 2. Start with what's given, okay? They say these are right angles, awesome. They tell us this, awesome, don't ignore that. And go ahead and mark it up, okay? Also think about the reflexive property. Do we have a reflexive property? Now again, what are we looking for? We're looking for a hypotenuse and a leg, okay? So try to find your hypotenuse, try to find a leg. And yes, they did give us something here. What is this? Is this the leg or is this the hypotenuse? Okay, and whatever you say it is, find the other piece, okay? All right, guys, good luck, and if you have any questions, let me know. That guy's got it all figured out. He really does.